Session 5.4 Finding Probabilities for a Normal Distribution. Properties of a normal curve. A normal curve is unimodal and symmetric. Look at the curve in here. We say this is unimodal because we only have a 1 month. And the frequency start low, reach to the maximum, and go back to the low again. And this is about symmetric. So we call this as the normal distribution. Or you could say this is the bell shape. For a normal distribution, the mean is equal to the median, and both of them will be happen in the center. Okay, so that will be the mean equal to the median, and again, it's in the middle. Area probability equality property. The area under a normal curve for an interval is equal to the probability of randomly selecting an observation that lies in the interval. This is talking about if you randomly pick one data. And if we want to find the probability, means we are looking for the area. I want you guys write it down this one. Probability equal to the area. If for these sessions, if we are looking for the probability, means we are looking for the area. And the total area under a normal curve is equal to 1. Highlight this one also. This is talking about the total area under this curve will be equal to 1. Example, sketching the normal curve. Suppose that a pre-statistic class take a first test and the student scores are described well by the normal curve shown in the figure. So you could see, highlight this one, normal curve. So you know normal distribution, that will be the bell shape. Frequency start low and reach to the maximum, go back to the low again, and it's about symmetric. Okay, so this is meanings like normal curve. What is probability? A randomly select student scored more than 80 points. So first, 80 points, this is in the middle. Remember, when you have the normal distribution, the mean will be equal to the median. So you could know this is going to be your mean equal to 80. And they're looking for the probability that if you only pick one student and his or her score is going to be greater than, okay, more than 80 points. So more than 80 points, that will be the area on your right hand side here. Remember, what is the total area under the curve? The total area under the normal curve will be equal to 1. And you can see right now we cut it half of it. So you're gonna know the area of the white here, that will be equal to 0.5. Okay, one more time. When you want to find the probability, means you're looking for the area. And for this picture, the total area under the curve is going to be 1. And since we cut it half, and we know this is going to be symmetric. So 1 divided by 2, you're going to get the 0.5 in here. So we would say the probability to pick a student scored more than 80 points is going to be 0.5. Number 2, on test 2, the mean score is 20 points less than the mean score on test 1, but the standard deviation is the same. Assuming the scores are still normally distributed, sketch the curve and describe the score. So we have the test 1 score pictures looks like this. And then on the test 2, the mean score is 20 points less than this one. So we're going to subtract 20 from here. And you know that the mean of the test 2 score will be the 60. Okay, will be like here. But the standard deviation is the same. This is talking about the shape and the spread of the distribution is exactly the same thing because the standard deviation doesn't change. So what we need to do, we just need to shift this picture 20 points to the left. And one more time, standard deviation doesn't change, means the spread of the data and the shape is exactly the same thing. On test 3, the mean score is the same as on test 2, but the standard deviation is larger. So look at the picture of the test 2 score. The mean doesn't change, so we still keep on the 60 in here. But the standard deviation is larger, so we know that we're gonna sketch the curve much wider, okay, much wider than the test 2 score. Since we sketch it much wider, we have to make it like more flatter because the total area under the curve has to be 1. If you make it wider, you have to make it like flatter compared with the test 2 score. It's gonna be looks like this. We could calculate that each little square in the grids of the both test 2 and 3. Make sure when you add it up has to be equal to 1 in here. Okay, comparing normal curve with different standard deviation. A normal curve for distribution with larger standard deviation will be wider and fatter than a normal curve for a distribution with the smaller standard deviation. We just do the example 2 and 3, we could compare with the standard deviation. If you have the larger standard deviation, the distribution will be wider and fatter. Okay, because we have to make sure the total area under the curve is going to be equal to 1. If you have the smaller standard deviation, then the distribution will be narrower and it's going to be taller. Empirical rule. If a distribution is normal, then the probability that in randomly select observation lies within one standard deviation of the mean is approximately 0.68. Look at this picture. This is the normal distribution. Okay, so the mean will be in the middle. Empirical rule saying that if you only add one standard deviation here or subtract one standard deviation here, and this part, the yellow part here, this is consists like 60% of your data. If you add from the mean 2 standard deviation or subtract 2 standard deviation here, then by the empirical rule, we do have a 95% of the data in here. If you plus minus 3 standard deviation, then that will be counting like 99.7% of the data. I need you guys to remember that empirical rule, it only applies for the normal distribution. And you need to remember that within one standard deviation, okay, within one standard deviation means you plus one standard deviation or minus one standard deviation. They are about 68%. Plus minus 2 standard deviation, that will be about 95% of the data. If you plus or minus 3 standard deviation, they are about 99.7% of the data. C-score. The C-score of an observation is the number of the standard deviations that the observation is from the mean. Okay, first look at this picture. This is the normal distribution, so the mean will be in the middle here. And what is the C-score? C-score is measure how many standard deviation above or below the mean. So think about it. I draw one more line. This is talking about the C-score. At this point here, that's a no standard deviation in here. So my C-score, that will be equal to 0. And this is talking about the mean plus 1 standard deviation, meaning that there are 1 standard deviation above the mean. So my C-score will be equal to 1. And here, this is the mean plus 2 standard deviation. So there are 2 standard deviation above the mean. So the C-score will be equal to 2. Same idea here, plus 3 standard deviation. So C-score will be equal to 3. Okay, now this one. This is the mean minus 1 standard deviation. What do you guys think about the C-score is gonna be equal to? that will be equal to -1, right? The negative means 1 standard deviation below the mean. And here, that's a 2 standard deviation below the mean, so that will be the -2. And 3 standard deviation below the mean, so we use the -3 here. And how can we find my z-score? We could using this formula. Okay, the x here represent your data minus your sample mean divided by the sample standard deviation. Example, compute and interpret a z-score. The 2014 draft picks for NBA basketball teams have a height that are approximately normally distributed. Okay, normally distributed. This is talking about this as a normal distribution, with the mean 79.1 inch and standard deviation 3.0 inch. Shabazz Napier was the shortest 2014 draft pick with a height of 72 inch. Find the z-score for the 72 inch. What does it mean? So we are looking for the z-score. So we have this formula here. And x represent your value. So this is going to be 72 inch in here. And what's the mean? 79.1. Standard deviation will be the 3 here. So plug it in. Use your calculator to see what you guys get. You will get -2.37. Okay, this is the z-score. Z-score. Because the z-score of the data is the number of the standard deviation above or below the mean. So we could restate the empirical rule in terms of the z-score. 68% of its z-scores lie between -1 and 1. 95% of its z-scores lie between -2 and 2. 99.7% of its z-scores lie between -3 and 3 here. Okay, standard normal distribution. If a distribution is normally distributed, then the distribution of the data's z-score is also normally distributed with the mean equal to 0 and standard deviation equal to 1. And we call the distribution of the z-score is a standard normal distribution. I want you guys to highlight the standard normal distribution. Every time when we talk about this is the standard normal distribution, you need to remember the mean will be equal to 0, standard deviation will be equal to 1. Okay, one more time. When you have the standard normal distribution, the mean will be equal to 0. Standard deviation, that will be equal to 1. We do have a 2 method to finding the probability. The first one will be using the table A2. Okay, the table A2, the z-score table. If you're using the table A2, it is essential to understand this point. Okay, you will have this 2 page of the paper. Okay, look at this 2 page of the paper. This is called the table A2, or you could call this is the z-score table. First, this table is only designed for the standard normal distribution, means you only can find the probability when you have the mean equal to 0, standard deviation equal to 1. It's designed for the standard normal distribution. 2. Table A2 is on 2 pages, with the left page for negative z-score and the right page of the positive z-score. So look at the table here. You should have 2 pages. On the left-hand side here, you could see that's a Z. This is represent your z-score. Okay, the z-score. First page, you will have the negative numbers. Second page, the z-score, this is the positive numbers. Okay, so the 4 digits numbers in the middle, this is represent the area. Means like this is represent the probability. Okay, one more time. You do have the z-score from here, here. 1 positive, 1 negative. The 4 digits number in the middle, okay, in the middle. This is represent the probability, means this is represent the area. Every time when you're finding the area from this table, this is the area always cumulative from the left to the right. Okay, always cumulative from the left to the right. Let's try an example. Find the probability that a z-score randomly select from the standard normal distribution is less than negative 1.35. First, we are working on the standard normal distribution, so you know your mean is equal to 0, standard deviation is going to be equal to 1. Okay, so you should have this picture. The mean equal to 0, so that will be in the middle here, that will represent your 0, plus 1 standard deviation, 2 standard deviation, and 3 standard deviation. And this is also equal to your z-score. When we want to find the probability, that's less than negative 1.35. So negative 1.35 is somewhere like here. And we want to find the probability. Remember I say probability will be equal to area. And we are looking for the area less than this number. So means we are looking for the area in this part. Okay, now let's look at the table A2. We have a two page, right? One is a negative numbers, one is a positive numbers. Right now my z-score is negative 1.35. So I want you guys look at the z-score with the negative numbers. And then we are working on negative 1.35. So finding from the left hand side here, negative 1.3 is going to be here. The 2 digit here will be on the top. So negative 1.35. Okay, you could see the 0.5 here. When you add it up, it's going to be negative 1.35. Okay, so finding the probability, which is going to be here. Okay, you're going to go to the right here, and then the 0.05, go down. You're going to find the value 0.0885. And this is the area on the left. Okay, this is the area less than the z-score negative 1.35. Okay, one more time. This table only works for the standard normal distribution. And the area is always cumulative from the left to the right. Okay, another example. Earlier in these sessions, we worked with the IQ test, which measures a person's intelligence. We call that the people's IQ score are normally distributed with the mean 100 points and standard deviation 15 points. Let X be the IQ points of a randomly select person. Find the probability that a randomly select person has an IQ less than 78 points. So first, this is talking about normally distributed. So we know this is a normal distribution as well. But this time, the mean is equal to 100 points. Standard deviation equal to 15 points. And we know that this is called non-standard normal distribution, right? Because if standard normal distribution, mean will be equal to 0 points, standard deviation will be equal to 1. Right now, the mean equal to 100 points, standard deviation equal to 15 points. So we know this is called non-standard normal distribution. So first, sketch the picture. We have the normal distribution with the mean equal to 100 in the middle. And then we want to find the probability. Means we are looking for the area less than 78 points. So less than 78, 78 will be less than the mean in here. Okay, we are just approximate. X equal to 78 is about like here. And then we draw the line here. And we want to find the area that's less than 78. Means we are looking for the area on your left. Okay, since this is the non-standard normal distribution, if we want to use the table A2, we have to convert it to the C-score. Okay, we have to convert it to the C-score. Remember we learned the formula from previous example? We do have this formula, right? Finding the C-score when you know about the X in here. So now I want you guys plug it in and tell me what you guys get for the C-score. Okay, x equal to 78 minus the mean divided by the sample standard deviation. You should get negative 1.47. Okay, your C-score will be equal to negative 1.47. Okay, we converted from the non-standard normal distribution to the standard normal distribution. Now you know the C-score. Can you guys look at the table A2, find out the area from the left? We have the negative C-score again, okay? So look at the negative C-score, finding negative 1.4 and 7. Tell me, what did you guys get for the area? You should get 0.0708. Okay, let me show you guys one more time. Okay, negative 1.4 is going to be here. Negative 1.47. So that will be 0.07 is going to be here. So you should find out this number. Okay, 0.0708. Okay, 0.0708. The area we always want it to 4 decimal space. For the C-score, normally we want to 1 to 2 decimal space. Okay, number 2, greater than 117 points. So x equal to 117 points, somewhere like here. And we want to find the probability that's greater than 117 points. So greater than means like we're looking for the area to the right. So first step, convert it to the standard normal distribution. Use the C-score formula. Plug it in. You should get 1.13. Okay, your C-score should be equal to 1.13. Okay, look at the Z-score table. This time, we're looking for the positive one. Okay, 1.13. You should get 0.8708. Okay, 0.8708. And remember I say the area that you're looking from the table A2, this is always the area from the left. Okay, the area from the left. So the 0.8708 is talking about the area in this part. But right now, we are looking for the area greater than. So it's going to be on your right-hand side here. Think about it. How can I figure out what is the area to the right? Remember, what is the total area under the curve? The total area under the curve should be equal to 1, right? So we could subtract it. Okay, 1 minus the area from the left. You should get 0.1292. This is how we're using the table A2. If they given the C-score, how can you find the probability? Okay, again, probability means the area. Okay, method 2, use the calculator. You could use the table to find out the probability, or you could use your TI-83 plus or TI-84 plus calculator. And then you will follow like this instruction. Go to the second VAS and then finding the normal CDF. You're gonna plug in the first value, the lower value, and then the upper value, and then enter. Let's look at this example. Let's say I have the normal distribution. Right now, I want to find the area to the left. And I know my C-score that will be equal to 0. Okay, you could try to look for your table. When the Z-score equal to 0, what's the area from the left? But this time, I want to use the calculator. You could see this is a normal CDF, lower value to upper value. Okay, the lower value is talking about the value on the left in here. Okay, what is the smallest number in this point here? We call this is a negative 1D99. Negative 1D99 means negative 1 times 10 to the power of 99, which is really small numbers. So if we want to use the calculator, that will be the normal CDF, the lower value starting on this point, negative 1D99, cumulative to 0. Okay, we stop at 0. So we want to find the area cumulative from this point until 0, means like this part. You could guess it's gonna be equal to 0.5, right? Because the total area under the curve is 1. Cut it half is gonna be 0.5. I just try to use the calculator so you guys how to find the area to the left in here. Okay, let's say this time I want to find the area to the right. So what is the lower value for this time? We're gonna start at this point. The lower value will be equal to 0 to the upper value. What is this value in here? That will be 1E99, positive 1E99. Positive 1E99 means 1 times 10 to the power of 99, which is really big number. If I want to find the area to the right, I'll be using the normal CDF again. Cumulative starting from 0 to 1E99, which is gonna be equal to 0.5 as well. Okay, let me show you guys how to use your calculator. Before we're working on this example, I want you guys go to the setting here. Go to the mode. Can you see the mode here? Next to the second. And then go down. You're gonna find the stat wizard. Okay, stat wizard. I want you guys turn it off. Okay, use the arrow button, go to the right and enter, turn it off. If you're using the TI-83 Plus, don't worry about this part. You don't have this guy. Only some of the TI-84 Plus have this function, the stat wizard. Turn it off. And then click on second mode. It's going to be quick. Okay, set it up before you're working on this example. Now, we want to do normal CDF. So first, go to the second. This is a second VAS. You're going to see the VAS here next to the clear. For the number 2, you're going to see that's a normal CDF. Enter. So the first value, let's try the first one in here. Negative 1E99. The negative, make sure you use the one below the 3. Okay? Negative 1. The E, don't use the green color for this guy. Use the comma one. Did you see the comma? That's a double E here. We're going to do second comma. You're going to see the E. And then 99, comma, 0. Close it. Enter. You're going to see that 0.5 in here. Okay, let's try the area to the right also. Second, VAS. Number 2, normal CDF. This time we're starting from 0, comma. Positive 1. Again, the E use the comma with the double E here. Second, comma, 99. Close it. Enter. That will be equal to 0.49999. If you want it up, it's going to be equal to 0.5 as well. Now let's try to redo the example. The first two examples, we use the table A2. I want to do it one more time and use the calculator. So find the probability that the z-score randomly select from the standard normal distribution is less than negative 1.35. So again, this is a standard normal distribution. We know the mean equal to 0, standard deviation equal to 1. So we have this picture, negative 1.35, somewhere like here. And we're looking for the area to the left, okay, less than, so the area to the left. So think about it. What is the lower value? What is the smallest values in here? We'll be using negative 1e99, right? So we will have a normal CDF starting from this point to negative 1.35. When you guys using the normal CDF, this is always calculating the area from the left to the right. Okay, so don't mess up the order from here. Okay, use the calculator. You should get 0.0885. Go to number 2, normal CDF. Again, negative, use the 1 under the 3. Negative 1, second, comma, 99, comma, negative 1.35. Close it. Enter. You will see 0.0885. Okay, so this is how you guys using the calculator when you have a standard normal distribution. When they given the z-score, you use the calculator to find out the area. Okay, second part. We already learned how to find the area if they given the z-score, right? The normal CDF, lower value and upper value. And then, what if they given the x and you want to find the area, just like the example 2? You'll be follow like this instruction. Same idea, go into the second VAS, finding the normal CDF. The only difference between the z-score here, you put in lower value, upper value, and then you're gonna plug in the mean and also the standard deviation. Because when they given the x, means this is a non-standard normal distribution. So we don't know about the mean, we don't know about the standard deviation. So that's why plug it in, lower, upper, plug in the mean and the standard deviation. Okay, try the example again. Okay, we do have the same IQ test example, and we want to find the probability that a randomly select person has an IQ score less than 78 points. So draw the picture here. We're looking for the area to the left. Since we're using the calculator, you could skip using the z-score formula. Okay, just look at it. What is the lowest points in here? Same thing, that will be negative 1e99. So use the normal CDF starting from negative 1e99 to 78. Make sure you plug in the mean and also the standard deviation. Okay, the mean and the standard deviation. You could get 0.0712. Try it on your calculator. So second VAS, number 2. Negative 1, second, comma, 99, comma, 78, comma, 100, comma, 15, close, enter. So you're gonna get 0.0712 here. Okay, try the number 2. Find the probability that is greater than 170 points. So 117, somewhere like here. we want to find the probability greater than, so the area to the right. And again, if you're using the calculator, you could skip the formula with the z-score. Just use the normal CDF. This time, lower value will be 117. What is the upper value here? That will be 1E99. Okay, so normal CDF, 117 to 1E99, the mean and the standard deviation. You could get 0.1285. Okay, I want you guys double check from the previous example, when we're using the table A2, we got the answer 0.1292. But right now, when we're using the calculator, we're gonna get 0.1285, right? The answer is gonna be a bit different from here. Why? Let's take a look for the example when we're using the table A2. Okay, this one. Okay, we got 0.1292 in here. Why I got the different answer? It is because for my z-score, I only want to 2 decimal space. If I try to want the z-score to like 6 decimal space or 7 decimal space, I would get like exactly the same answer when we're using the calculator. Okay, because the calculator here, when you're using the normal CDF, you plug in the x in here, they probably want it to the 7 or 8 decimal space for the z-score and then finding the area. So that's why it's going to be a little bit different. So for these sessions, I teach you guys how to find the probability, means like the area, using the z-score. And we use the 2 methods, the table A2 or the calculator. For my class here, it doesn't matter which method you use. You could use the table A2 or you can use your calculator. Just make sure write down which method you're using. You may get a little bit different of the answer, just like this example. But I highly recommend you guys try to understand the method 1 and also the method 2, because when you guys taking this math 227, some professor may only using the table A2. Some professor may use only the calculator. So it's better you learn both methods right now. Okay, interpreting the area under a normal curve for an interval. When we're finding the area under the normal distribution curve, this is meaning like we're finding the probability. Okay, we're finding the probability. Or this is means like you're finding the proportion of the data. Okay, proportion of the data, the same idea with the probability. That's it for this session.